Here is a question, which asks basically a 12 ohm resistor. So this is the 12 ohm resistor which draws 1 amp of current, okay, as shown in the figure. And what is given is basically what is asked is we have to calculate the resistance R. So there is a current source here, there is a voltage source here. So generally these kind of problems, when there is a current source given, so we first try to come up with the distribution of the current all across the nodes. So you can see here 2 amps is the current towards this resistor. That means here also it is 2 amps. Okay. So as per Kirchhoff's law, any current that is I1, let us assume this is I1, this is I2, this is I3. So at a particular node, I1 plus I2 plus I3 is equal to 0. Okay. So I1, let us take 2 amps, and then which is going inside, which is going outside, I2, let us take -1, and this, let us assume I3, okay, is equal to 0. So I3 is equal to -1 amp. So that means when we say this is going away from the node is -1, and this will be going away because it's a minus. So you can also see 2 amps is going here and it is distributed as 1 amp plus 1 amp. That's how we calculate the current. Now that we know the current that is transmitted, the current of 1 amp is going through this resistor, so which means there will be a potential of plus here and minus here. Because there is a current that is going through this, the potential will be developed as plus and minus. Okay, and we already have plus minus, which is a voltage source. This is positive, this is negative. Now if we put a Kirchhoff's voltage law, which gives V1 plus V2 plus V3 is equal to 0. When we start from this side, -6 and -1 into R, okay, and then plus 12 into 1. V is equal to IR, right? 12 into 1. So let us write it as 12 into 1 for the understanding of others is equal to 0. That means minus R plus 6 is equal to 0. So which meant R is equal to 6 ohms. So the value of resistance here for this current to be 1 amp is 6 ohms. So we can also check whether the 6 ohms is correct or not by doing a simple check. So this node, if you see this node, right, this particular node, so the current flowing is 1 amp and the resistance is 12 ohms. So that means the voltage developed here will be 12 volts, right? So this is 12 volts, this is 6 volts. So that means the current will be flowing from higher potential to lower potential. So that means 12 minus 6 by R. Okay, R we got 6, right, which is nothing but 6 by 6, which is equal to 1 amp. So as we calculated, this is 1 amp, this is 1 amp, so which gets satisfied. So that means the resistance value of 6 ohms which we calculated is correct. So this is how we tend to approach the problems with the KCL when there is voltage and current source and a network theory related problem is given. Thank you.